Dear students, today we'll see the spherical aberration. Yesterday we have seen the chromatic aberration. Chromatic aberration is due to the different wavelengths of the light. Now we will see the spherical aberration. Look now, when the aperture of the lens is large, suppose if you consider it's a double convex lens. This is a optical center. If this aperture means this, if this is large, then the rays which are near the edges will fall at Fm because they are called as marginal rays. After refraction, they will fall near the optical center. And the rays which are nearer to the pole, they will fall at a larger distance. It is called as Fp because they are called as paraxial rays. Means actually once the rays will comes out, they should meet at a single point to get the sharp image. But if this aperture is large, that is the focal length of the lens is large, then what happens? The rays which are towards the edge, there is more deviation for them and they will fall nearer to the optical center. They are called as marginal rays. They will meet at Fm. And the rays which are nearer to the optical center, they will fall just little far away and they are called as paraxial rays. Means here the instead of sharp image, we will get this size of the image. So if we consider this distance, then it is called as longitudinal spherical aberration. Then it is called as longitudinal spherical aberration. Now the rays which are meet at the far distance, that is paraxial rays, so actually they form a circle of the different color. It's like this. So instead of sharp image here, so different colors are obtained in this particular region in a circular part. And the radius of this circle is called as lateral spherical aberration. It is called as lateral spherical aberration. Means remember, longitudinal spherical aberration is related to the distance and lateral spherical aberration is related to the radius. It is related to the radius. Now, ways to minimize spherical aberration. Ways to minimize spherical aberration. So how to reduce this spherical aberration? First way to reduce it by using the plano-convex lens, or plano-concave lens with the curved surfaces facing towards the incident light. Means suppose plano-convex lens is there. So this is a plane surface, this is a convex surface. So incident ray should face the curved surface, which is in this way. Or suppose plano-concave lens is there. This is a plano-concave lens. So here also this curved surface should face the incident ray. So by using either plano-convex lens or plano-concave lens, we will minimize this spherical aberration. Second way to minimize the spherical aberration is by using, so it is used by using, say, two convex lenses, one having larger focal length and one having smaller focal length. Larger focal length and smaller focal length. With larger focal length is towards the incident ray. Means first this length and then this, and they are kept at a distance of focal length of each other. Means whatever is the focal length of this, so another lens will be kept at that particular distance. Third, by using the combination of the lenses for different refractive index, suppose if you use the refractive index 1.5 for preparing the lens, then radius of curvature ratio R1 upon R2 should be 1 upon 6. And suppose if you prepare the lens by having the refractive index 2, then radius of curvature R1 upon R2 is 1 upon 5. So for the refractive index 1.5, radius of curvature of two surfaces, suppose if you use this as a biconvex lens, then the ratio of radius of curvature of first and second should be 1 upon 6. If you use n is equal to 2, then R1 upon R2 should be 1 upon 5. Fourth way, by using the combination of double convex lens and plano-concave lens. Plano-concave lens, where plano-concave lens is having larger focal length and double convex lens having smaller focal length. So by using this combination, also we will reduce the spherical aberration. So what do you mean by spherical aberration? When the aperture is large, that is thickness is large or size of the lens is large, then the rays are far away from the optical center also or nearer to the optical center also. The rays which are far away from the optical center, that is near the edges, they fall just say nearer to the optical center. They are called as marginal rays, and the rays which are nearer to the optical center, they actually refract at a large distance from the optical center. They are called as paraxial rays. Means the size, actually you should get a point size image at only one point only, but here the size of the image is from FM to FP. So this type of the aberration is longitudinal spherical aberration. It is related to the distance of the image. And if you consider the size means like this here. So for that, for the paraxial rays, colorful, once we pass the white light, then also colored rays are obtained in the circle of certain radius, say R. So that is called as lateral spherical aberration. Now there are four ways to minimize the spherical aberration. First, either by using plano-convex lens or plano-concave lens with the curved surface towards the incident light. Second, by using the two double convex lenses, one is having larger focal length and another having smaller focal length, and incident ray should face towards the larger focal length. Third, by taking the ratio of radius of curvature, different radius of curvature for the different refractive indices. For example, if you prepare the lens by having the refractive index 1.5, then the ratio of radius of curvature is 1 upon 6. And if refractive index is 2, then the ratio of radius of curvature is 1 upon 5. And then by using the combination of double convex lens and plano-concave lens of different focal lengths. Okay, so first we'll write this question. So right. Describe spherical aberration for lenses. Describe spherical aberration for lenses. State the different ways. State the different ways to minimize it. To minimize it. The first draw this first diagram. त्यांना वाटलं फिजिक्स सरांचाच प्रॉब्लेम आहे. काल बी तसं झालं अजून. मीटिंग आयडी आहे 1MDMTR हा झाला सर. हा कुठे आहे आपला? माझ्या शेतबुक कोणता आलं नाही. तिकडे नाही भेटलो तिकडे जायला इथं वेगळं आहे सर. मला वेगळं आलं 79889. हा कोणी पाठवलाय मग? हॅक तरी होते ना काही. नाही मुलं पण काहीतरी प्रयत्न खूप करतात. बाकीच्या कॉलेजचे पण एवढं खूप प्रॉब्लेम आहेत. पिंपरीत एक मुलगा सगळ्या Okay, finish.
Yes, sir.
Yes, sir.
First point, when a parallel beam of light when a parallel beam of light is incident on a convex lens rays incident near the edges of the lens edges of the lens focus at fm
Sir,
second the
Sir.
rays incident near the poles of the lens focus at fp next the distance between fm and fp it's called as longitudinal spherical aberration. Next point, a parallel beam of light passing through the lens would cause would cause to a circular path of image on the screen at fp the radius of this circle is called as lateral spherical aberration. Now give the heading, ways to minimize spherical aberration. First point, by using plano-convex or plano-concave lens or plano-convex lens, plano-convex or plano-concave lens with curved side, curved, curved side, facing the incident ray, facing the incident ray. Second point, certain ratio of certain ratio of radii of curvature for a given refractive index for a given refractive index eliminates eliminates the spherical aberration. Right, in that when n is equal to 1.5, when n is equal to 1.5, r1 upon r2 is equal to 1 upon 6. And when n is equal to 2, n is equal to 2, r1 upon r2 is equal to 1 upon 5. Third point, by using two thin convex lenses, two thin convex lenses separated by distance, separated by distance equal to their focal length, equal to their focal length with lengths of with lengths of larger focal length, larger focal length facing the incident ray, facing the incident ray. Next, fourth, by combination of by combination of double convex lens, double convex lens of smaller focal length and plano concave lens of larger focal length. Look, this is the theoretical end of the chapter. Now we'll see the numericals based upon this. But before we see the numericals, we'll write the important formulas. Since this chapter is very large, so many formulas are there. So you should start writing the formulas along with me.
No.
बाकीच्या नंतर देऊ का मग? भरपूर आहे. So now, right up to formula number 15, some more formulas are there, but because of the lack of the time, I'm not able to give it today because I got another lecture in 12th standard. So first we'll write those formulas, then we'll solve the problems. Next time you should keep the log table with you because whatever is the part which is required for the log table, side by side I will teach you log table. Log table is very small book, around 10 to 15 rupees, easily available in the market. So you can purchase that book and keep it with you so that I will teach you the log table part. Is that okay?
Yes, sir.
Yes, sir.
Sir,
Yes,
can you
sir.
give more?
Mm, mm, mm.
Again, look now, because of the technical problem, some of the students are not able to join this today's lecture. So as yesterday we sent the recorded lecture, today also for everyone, class will send the recorded lecture.
Okay, sir.
Okay, sir.
Sir. Excuse me, sir.